Hi everybody and welcome back to Chem Talk, where today we'll be talking about finding the formula from percent mass and mole ratios. So the first question that everyone should be asking is, why is finding the formula this way so important? So when we're given the full composition of the compound, when it's broken down by atoms or by elements, it helps in chemical analysis. Finding the final formula this way allows us to find the compound effectively and allows us to use it in future references with reactions as well as reagents, and maybe in a way of finding how to, use it and find it as a product in a reaction. So are there any real-life applications for this method? If you find a new compound, for example, while mining, you might want to know what the composition is, but you're not able to particularly find the formula just by looking at it with your bare eyes, because that's not possible at all. So you can find the percent composition with using an NMR or an IR spectra or something like that. And from using the percent compositions like that, you can find the final formula. And now you are the proud person of saying that you discovered a brand new compound. So typically in these problems, you're going to get the percentages and the final mass. So you're going to use the percentages to find the empirical formula and then the final mass to find the molecular formula. There's two different formulas that we need to know, and they're both very important when trying to find the final formula, which is the molecular formula. The empirical formula is the simplest whole number ratio of atoms present in a compound. So, for example, H2O is an empirical formula. If you multiply that by 2 or by 3, that's how you get the molecular formula, which is a formula giving all of the atoms present in one molecule of a specific compound. There is a general strategy when it comes to these kinds of problems. So the first step that you should be doing is finding the empirical formula using the percentages that you have been given. The second step is finding the mass of the empirical formula, which is by using mole ratios as well as the molar mass of each element. The third step should be finding the number of empirical units in the molecular formula using their respective masses. And then the fourth should be writing the final molecular formula. So let's apply this technique to an actual example. So on the screen right now, we're going to see example 1, which is finding the molecular formula of the following information. So we know that 75.46% of the compound is made up of carbon, 44.43% is made up of hydrogen, and 20.10% is made up of oxygen. We also know that the final mass of the compound is 318.31 grams per mole. So the first step that we should be doing is finding the empirical formula. We are allowed to assume that the sample that was collected is 100 grams, because this makes it a lot easier for us to turn the percentages into grams. So this means that we can assume 75.46% of carbon just equals 75.46 grams of carbon. We then use the molar mass to find the amount of moles there are. So you divide the amount of grams that you have, the 75.46, divided by the 12.00 grams, which is the molar mass, and you get the amount of moles that you have. You do this for each element that you have, and then you line it up in the way that you find it in a formula. So you need to find the ratio of each element, and you divide by the smallest number to get the largest ratio possible. We see that when dividing by the smallest number, which is oxygen, we get C5H7/2 and O1. Now the thing is that we don't see half numbers because it's not a full number, and according to the definition of empirical numbers that we saw earlier, halves and fractions are not allowed in molecular and empirical formulas. So what we're going to do is multiply this entire formula by 2, which is allowed because if you're multiplying all of the numbers by 2, we know that you're making every single one increase by the same amount. This allows us to find the empirical formula, which is C10H7O2. Now, using this empirical formula that we find, we're going to do step 2, which is finding the mass of the empirical formula. So you're going to multiply the amount of moles that you have. So you have 10 moles of carbon. You're going to multiply that by 12 grams, which is the molar mass. And you're going to do that for all of them. And you're going to find that the mass of the empirical formula is 159.06 grams per mole. The next step is you're going to find the amount of units there are in the molar formula. So the thing is you're going to divide the amount of the molecular formula mass by the empirical formula mass. This allows you to find the amount of empirical units there are in the molecular formula. And by doing this, we see that there are 2.001 units. You can just round to 2 because of the significant figures here. And with that, you can write the molecular formula. So that would be the empirical formula multiplied by 2. So we see that the final molecular formula is going to be C20H14O4. Sometimes you might be given the formula and you might be asked, what is the percent composition of each? So this is the following question. So example 2 states, calculate the mass percent of carbon, nitrogen, and oxygen in C2H5NO. Now we're going to follow the same exact steps except in the opposite order. So we're going to find the empirical mass, which is basically exactly what we did previously, which is multiply the amount of moles that we have of that element, multiplied by the molar mass, which would be for carbon, 12, and for hydrogen it would be 1.008, and you would find that the empirical mass is going to be 59.04, and then you're going to use that mass to find the mass percentage. So by using the amount of moles that you have of each, you're going to take the mass of each atom that you have. So say, again, you have 2 carbon. The mass of carbon that you have is 24 grams. You're going to divide that by the total mass, multiply that by 100 to get your percentage, and you're going to be able to see that you have 40.668% carbon. Now it only asks for carbon, nitrogen, and oxygen, but you're going to have to find hydrogen as well, because if you don't, you're not completely sure if everything adds up to 100. You want to make sure that all of your percentages add up to 100, just to be sure that you have counted everything there is in the formula. So after doing all the math, you see there is 8.533% hydrogen, 23.713% nitrogen, and 27.86% oxygen.